Hi, in today's video, we are going to walk through the challenge lab, creating a scalable and highly available environment for the cafe. Let's click on Start Lab and wait several minutes until the yellow AWS icon becomes green. And click on the link to open the management console. So we also need to click on the AWS details and click on Access the multiple choice questions to open the multiple choice question in a new tab. So switch back to the instruction. So in this lab, we are going to practice the creation of autoscaling group and attach it to a load balancer. So this is the target architecture. So we need to create two NAT gateways, one in each availability zones. And look, the NAT gateway needs to be sitting in the public subnet. And we are going to create a list of the EC2 instances in the private subnet within a autoscaling group. We also need to create a load balancer that has IP address in public subnet exposed externally. Therefore, we can access the Café website through the load balancer, and the load balancer will redirect traffic to the auto-scaling group. So let's go ahead first by inspecting the environment. So let's go to the questions and go through those questions. So one, which ports are opened in the Café SG? So go to the management console, click on EC2, and click on security group under the network and security. So check the Café SG. So click on inbound rules. There's one inbound rule allowing HTTP traffic. There's one outbound rule, basically allow all traffic. So which port are opened? So only port 80 are opened. So submit it, go back. Question number 2, can you connect from the internet to instances in public subnet 1? Public subnet 1. So we need to open the VPC console. So let's open a new tab and search VPC. Open the VPC console in the new tab. So let's examine the lab VPC. So click on the VPC ID. And here is the resource map for the lab VPC. So the question is asking about the public subnet 1. So let's highlight the public subnet 1. So as you can see, it connects with this public route table 1, and it connects to the lab IGW, right? So indicating that it's a public subnet that has internet access. So first, yes, if the instance has a public IP address and the security group and NACO allow it. So this should be the correct answer. Let's go through the others. Second, the public subnet has no internet gateway, which is wrong. We saw that it actually connects to the internet gateway. Third, the public subnet has no NAT gateway configured for it. So this is incorrect because only private subnet can go outbound through NAT gateway, not the public subnet. So this is irrelevant. Fourth, the network access control list prevent any inbound traffic from the internet. So let's check this. Let's go to the VPC for the public subnet. Let's click on to it. Let's open a new tab. And let's look at the network ACO associated with that subnet. And as we can see, for the inbound rule, all traffic are allowed, same as for the outbound rule, indicating that the netcode does not restrict anything, right? So this is also incorrect. So the first choice is correct. Submit it. Number 3, should an instance in the private subnet 1 be able to reach the internet? Private subnet 1. Let's go back to the resource map. Private subnet 1. As you can see, this is private subnet. It connects to this private route table 1, which also associated with the NAT gateway, right? So indicating that it actually can route the traffic to internet through the NAT gateway. So yes, so the answer should be yes, right? Fourth, should the instance in private subnet 2 be able to reach the internet? So let's check that. Private subnet 2. As you can see, private subnet 2 associated with the private route table 2, but it does not go connects to the NAT gateway. Therefore, all the traffic can only be local, right? Only local traffic can be routed. It cannot access outbound. So the answer should be no. Only local traffic, no internet traffic. Number 5, can you connect to the Café web app server instance from the internet? So the Café web app server. Let's go to the EC2 instance, click on instances, and check the instance ID. So it has a public IP address. So if it's in the public subnet, so most likely it will be able to be accessed through internet. But let's double check the networking. Click on networking, and we can see it is actually being deployed within the private subnet 1, right? So the answer should be no, because it's in the private subnet and it cannot be accessed from the internet, even though the server itself can go out to internet to retrieve, for example, patches through the NAT gateway, but the internet traffic cannot be routed into this server. So the answer is no. 6, what is the name of the Amazon machine image? So go back to the EC2 console, click on AMIs. There's one custom AMI, which is called Café Web Server Image. So Café Web Server Image, that's the one. Submit. So yeah, we examined the VPC environment for this lab by going through the questions. Okay. And next, we need to update the network to make sure it works across multiple AZ. So by looking at this target architecture, right? So we need to have 2 NAT gateways, one for each AZ. So keep in mind, internet gateway is high available by default. So you only need to create one internet gateway and associate with VPC, and it will take care of traffic for multiple availability zones. But for NAT gateway, the best practice is that you need to create one for each AZ. So it's not high available by default. you need to create a NAT gateway for each AZ, right? So, and for any for private subnet for private subnet 1, it route traffic through the NAT gateway in the public subnet 1, right? And for private subnet 2, it should also route traffic to the NAT gateway sitting in public subnet 2, right? So each NAT gateway will take care of the traffic within that AZ. So let's go back to the VPC console. So by looking at the resource map again, right? So for private subnet 1, it's associated with a NAT gateway, and for private subnet 2, which is in a different AZ, US East 1B, we need to therefore create another NAT gateway in the same AZ and route it through the private route table too, right? So basically, we need to do these 2 steps. So first, click on NAT gateways to create another NAT gateway, and click on create NAT gateway. So let's say second NGW. The subnet should be the public subnet 2. Remember, NAT gateway needs to be created within public subnet. And in this case, we're creating the subnet in US East 1B because there's already one existing in US East 1A. So Elastic IP need to allocate it. And with that, we click on create NAT gateway. And the second, we need to click on route tables and check this private route table too, right? So click on route table ID, and we need to edit the route by add a external route to the second NAT gateway. And click on save change. We can verify the design, verify the implementation by look at the resource map again. Right, private subnet 1, same. Private subnet 2, right? So it gets routed to the second NGW. So the network is set up. Now let's move on to create the auto-scaling group. So we need to first create a launch template. So go back to the EC2 console and click on launch templates within the instances menu. So click on create launch template. Call my template. So for the template contents, click on my AMIs. So and select Café web server image, which should be selected by default. And in terms of the instance type, select t2.micro. For key pair, we are going to create a new key pair. Use a ppk called demo key. So the key pair has been created and downloaded as well. So for the network setting, we are not going to include in the launch template. So we move on with the security group. We select the security group that has a Café SG in the middle. Under Resource tab, we're going to create the name tag with the value of web server. We also need to specify the IAM instance profile by expand the advanced details and under IAM instance profile, select Café role. And then click on create launch template. So launch template is just a configuration file, so it should be very fast to be created. So once the launch template gets created, select it, click on action, and select create auto scaling group. So put the name, let's say my ASG. Launch template, that's the template I just created. So, and click on next. We need to specify the network details. So we first select the VPC, which should be the lab VPC. So we will let the auto scaling group to be spanned across two AZs, right? US East 1A and US East 1B. So, and we also need to use the private subnet. So US East 1A, and US East 1B. Right, so the reason is that the EC2 instances within the auto-scaling group needs to be created in private subnets. So, and click on next. So we're not going to attach to a load balancer yet. So we're going to create a load balance later on. So we keep all the default setup, click on next. In terms of the group size and the scaling policy, let's start with a desired capacity of 2, and the minimum also set to 2, the maximum set to 6. So, and we're going to use the target tracking scaling policy based on the average CPU utilization with a target value of 25%, and instance warm-up, let's make 60 seconds. So with that, we keep all the other options as is. Click on next, click on next. We're not going to create a tag, click on next, and click on create auto scaling group. So, and wait until the auto scaling group gets created successfully and the status changes to ready. Now let's move on to create a application load balancer. So close this, we click on EC2 and click on load balancers. And we click on create load balancer. Under the application load balancer, click on create. So let's put a name, my ARB. So it's internet facing. It's IPv4. For VPC, we select the lab VPC, and we need to select at least 2 AZ that use US East 1A, US East 1B, and remember the subnet needs to be the public subnet, right? Therefore, the load balancer can be accessed from internet. So make sure you select public subnet 1 as well as the public subnet 2. In terms of security group, we remove the default one. We need to create a new one, right? So we can click on create a new security group. Let's call web SG. Allow HTTP traffic. VPC is lab VPC. Add inbound rule. So it should be HTTP. Source is anywhere, right? So that's it. Click on create. So let's go back to the previous tab. We refresh the security group list and select the newly created web SG. So for listener and route, we need to create a target group. Right, so click on create target group. And select target type as instances because we are actually going to use a list of the EC2 instances as the target. Target group name, my TG. So it's HTTP, lab VPC. Keep the other option as is, click on next. So we are not going to manually register target. We're actually going to allow the autoscaling group to handle that. So here we're not going to manually register target. So we just click on create target group. Okay, and go to the previous tab, refresh the link, and the newly created myTG will be there. Select it. And leave the other option as is. And click on create load balancer. So, and go back to the my ALB page, and then you can see the status is in provisioning state. Wait several minutes until it's completed. So wait until the state becomes active. So next step, we need to update autoscaling group to associate with the load balancer, right? So we can do that by click on autoscaling group from the left-hand side and click on my ASG. So click on integration. So we don't have any load balancing associated. We need to do that by click on edit and select the application load balancer target group and select the my TG and click on update. Okay, so we can verify the setup by going to the load balancing target groups. So click on my TG, and then we will see that the two web server will be available under the targets. So now let's go ahead and test out the web server through the load balancer. So let's click on load balancers. and click on My ALB. So this will display the detailed information of my application load balancer. So I'm more interested in the DNS name. Let's copy it and open a new tab. Type http semicolon // and paste the DNS name. So hit enter. So you will see the hello page indicating that, yeah, we were able to access the web application through the load balancer. So if we appended URL with / Café, you will be able to see the Café site. We can play around with it. Looks like the database configuration is not done. So if you were not able to access this website, there are several places you should double check. So first of all, the security group that's associated with the load balancer, right? So go back to the load balancer and click on the security. Make sure that you have a security group which allows HTTP traffic as the inbound rule, right? So that's the first thing you need to double check. And the second, you need to check the instances, the EC2 instances. So let's click on the target group, click on targets. There are 2 instances, right? Let's click any one of them. So first, we need to make sure that it's in the private subnet, either private subnet 1 or private subnet 2. It needs to be in one of the private subnets. Second, which is very important, that you need to make sure that, yes, it has the Café role that's being attached to it. So lastly, you need to double check your VPC configurations, right? So go to the resource map for the lab VPC to make sure that you have the private subnet 1 connects to the NAT gateway, and you have a private subnet 2 connects to a second NAT gateway as well. And you have a public subnet that connects to the internet through the lab IGW. Same is for the public subnet 1. So make sure those network setup are correct. Okay, next, let's test out the auto scaling. Let's create some load test to simulate that. So similarly, we're going to use AWS System Manager, Session Manager to connect to one of those running private web instances. So how? Let's go from beginning. Click on load balancers, right? So, and click on the target group. Click on targets. Click on any of those registered targets, for example, the first one, and click on connect. Session manager, connect. So in the terminal, let us first install third-party tool. And also install the stress test utility. And then let us run the stress test. Run CPU. Let's keep it running. For 10 minutes. So yeah, let's wait for several minutes, and meanwhile we will examine the number of web server instances periodically. So in fact, after several minutes, if you go back to the EC2 console, click on Autoscaling Group, for example, click on My ASG, and click on Instance Management, you will see that 6 instances have been created because of the increased load. So we can actually click on the original instance that on which we running the load test, right? So the instance ID is the one, and with 49C, this one, right? So we click on that instance and click on monitoring. We will actually see the spiking CPU utilization for that instance, right? So, which triggers the alarm, which in turn triggers the creation of additional instances. We can verify that by going to the CloudWatch log, CloudWatch, and click on all alarms. So 2 alarms have been created because of this auto-scaling group. And if we click on this first, so we will actually see that for a period of time during which we are doing the load testing, it's actually in alarm, triggering the creation of those additional instances, right? So that concludes today's lab. Don't forget to go to the instruction, click on submit, and yes to submit your work. And wait several minutes until the grading is completed. And then click on grades to display your total score. Don't forget to make a screenshot and capture the total score and include that in your submission report. So with that, we can safely terminate the lab environment by clicking on end the lab, click on yes, and go to the management console to log out from this console session. So that concludes today's video. I will see you in next.